Hello world, this is Craig. So I populated these boards with the components I had, and while I was doing that I placed an order with DigiKey for the things that I didn't have, and that came in and I populated those. So I thought I would do a little video on an update of the boards at this stage. Now, keep in mind I haven't tested anything yet. All I've done is populated the boards, and this is an update as to how that went. So first of all, there were very few issues that came up. None really to speak of, except for maybe hole size on a couple of places was an issue, but overall the BOM worked very well. The bill of materials was very accurate. There were only a few mistakes I found. One of the things that would be useful in the BOM would be to have a table that tells us, breaks down which components are on which boards. And so, for example, let's say I've got a 300 ohm resistor. I look at the BOM and it says I need 15 of these, and so I pull out 15 of them from my envelope, I bend the leads, and then I've got these sitting on the bench, and I like to go through and populate that one component on all the boards at the same time. That way I only have one resistor out at a time, and there's just less chances of mistakes, and it would be nice to have a table that said, okay, this many go on each of the boards. It would have sped things up a little bit, but not a big deal. Something that about these boards, I'm not sure I would have done it the same way or not. I haven't actually decided yet, but pin 1 isn't marked as a square pin, and that's a fairly recent thing to do, is to mark pin 1 with a square pad, and a lot of my vintage boards don't have it, and so it would be a decision between making this authentic reproduction and making it a little bit easier to debug. So I think I've discovered it in the early 80s that people started making pin 1 square, but I'm not sure what decision I would have made on this, but I think I probably would have made pin 1 square just because I like to have it when I have the board flipped over and I'm debugging the back of it. Okay, so just wanted to go through the boards real quickly. Oh, one other thing that I did notice on a lot of the boards, the bypass capacitors I think is mislabeled for the polarity in many cases. But I used ceramic monolithics instead of tantalum for the bypass capacitor, so it didn't really affect me. But if you are using polarized capacitor for the bypass, I think you might want to check that a little bit more carefully. Okay, so this is the 8008 board, and populated. So let's just quickly go through these and see what they look like. This is the teletype board. So remember, what this one does is the restart board. When it gets the start bit from the teletype, it kicks an address for the interrupt onto the bus, so it can go service that teletype input, and also it puts the address on the bus during a fresh restart. Okay, this is the buffer board for the 8008 to latch the address and drive some of the drive all the lines. Nothing special or anything interesting happened on that. The ROM board, I haven't put the address in yet. Okay, so I made 3 of those while I was doing it. And I'm sorry, that was the ROM board. This is the RAM board. Same thing, I haven't put the address in yet. But nothing, I don't think anything was interesting on populating that. This is the input board. Haven't put the address in yet, but nothing special about that again. This is the output board, and this one I have put in the page address and the port address. And I think I will, my next video, I think I will talk a little bit about this board, because one of the things that's interesting in this, I'd like to get some feedback on it, is they used an open collector for the driver, and it's just an interesting place to use an open collector. It's not, I have 3 or 4 reasons why I would use open collector, and this isn't any of them. So it's interesting about this, and so I think next I'll do a video on this board. This is maybe one of the first boards that I test. I'll talk about that a little bit later. Here's the 8080 board. Again, nothing special. All the components fit nicely. And then the only other 2 boards are the power supply board and the backplane board. So the backplane board, this is the backplane board. Everything went together nicely with a couple of exceptions. One is this transistor, which is the main pulse transistor that drives the programming pulse on the the EEPROM programmer. And on this chip, the holes were too, or on this device, the holes were too small, so I had to take the motor tool and cut about a third of that off to get that to go into the hole. The other thing is some of the larger wattage resistors and some of the diodes, the lead was just marginal, and so I had to, and some of them just scrape the lead with a razor blade to just get off any excess tin on the lead to get those to go in the hole. The power, I had this mounted with the power coming from the socket from the top, but then I found a little hammered box that I'm going to mount this in, and so I decided to put the power supply in that box also, and so I redid this and I hardwired the wires for the power coming out of the bottom. The only other thing I did on this that regarding the teletype connector, I'm not sure how they originally had this amp connector mounted. I've seen some photographs where they basically had just drilled holes into this and then kind of kludged it onto the traces. I'm not sure if that's the way they originally did it or if they just originally had holes that were large enough for the connector solder cups to fit through, but at any rate, I decided to go ahead and take some of the leads that I cut off from the components, solder them into the connector, and then put this on standoffs and solder those leads into the board. So rather than drill holes in the board, that's the way I decided to go ahead and do that. I thought it looked a little bit cleaner, although probably not original. And then that brings us back to the holes for the backplane connectors. And I mentioned before these were too small. I came really close to doing to drilling these out and putting in some plated through rework grommets. And for the memory, there's only one top trace, and those would have been easy to do for the memory. For the I/O, though, there's several traces that are on the top, and then for the processor card and the buffer card, there's quite a few on the top. So if there hadn't been as many on the top, I would have just drilled them all out, and then the ones that did have a trace on the top, I would have put in a rework grommet, a plated through grommet that you'd then swage in there and solder it to the trace on the top, so that I could use a standard card on these. Particularly, I could have used my cards that have the guide on them. But Charles gave me the fellow, the eBay that he ordered the connectors from. They're supposed to be just a standard wire wrap one, and so I ordered those, but they're coming from Asia someplace, so they won't be here for another week or so. I will try those, take a look at those, and see if I want to go ahead and do that route. That would be ideal, I guess, to just put the wire wrap connectors in. But I'm sure that that's a problem that's going to go away the next time that they make a run of these boards. I'm sure he'll put in the right sized holes on those. Okay, so that was the only thing that happened on the backplane board. There's a few places where the capacitor values are odd. I'm never qualified to second guess somebody else's capacitor choice, although I do it. I'm not really qualified. There were some odd capacitor choices, I thought, and then some pretty funny resistor values that I had to order. But other than that, the backplane went together very well. And then the last one is the power supply board. I'm not sure why these turned out to have such a different footprint. The regulator, I forgot to order a mica insulator for that, and the reason I want to put this on a insulator is there's traces underneath this, and the heatsink is live, and I don't want that heatsink right up against these, just on this solder mask for these traces. So I'm going to put a mica insulator down first to help protect those from wearing through. And of course, the reason we use mica is it's never going to creep. We'll take that back off in 50 years, and it'll be just as tight as it was the day we put it on. Okay, so that is all of the boards, and as I said, those all went together nicely. Nothing else worth mentioning. Very happy with that so far, and I'm going to start firing those up. So the next thing I'm going to do is check for any bridges on the back, and that there's no cold joints, and take the flux off. I did have to, one of the downside of using old components is you know, when the eco-friendly solders first came out, they weren't all that great. So some of these components were really hard to get them to 10 or to get a good solder. So I wound up having to either dress them a little bit with file or sandpaper, or scrape them with a razor blade, or just use a lot of flux. And so I got quite a bit of flux on the back of this that I got to clean off. So I'm going to clean these off, make sure that there's no bridges, no cold joints, and then clean the flux off. And then the individual boards, I made a little jig here that connects up to the power supply, and it connects up to my trusty 8010B, my little Intel single board computer that I have here for the 8010B. And I'm going to use this to basically, I have 48 pins on my 8010B that I'm going to use to just bit bang the address and the handshaking lines to test individual boards. So the first thing I'm going to do is take the board. So for example, my output board, plug my output board in, turn the power supply on, and go around and check to make sure that all of my polarized capacitors are in correctly. You know, with the tantalums particularly, they can take quite a bit of reverse polarity. So, you know, if you have a 16 volt tantalum, 25% reverse polarity is no problem for it. It'll have a higher leakage current, of course, but it's not going to get so high that it's going to destroy the component. Now you get up to 50%, and it'll certainly shorten the lifetime. But even at 50%, some of these would probably last for hundreds of hours before they finally popped. So rather than take the chance, and there aren't that many of them, I'm just going to put the power supply to it and go around and check to make sure all the positive leads are what they say they are. Then the next thing I'm going to do is plug it in. So this goes into my little test socket here, and I have some code that I've started writing for actually, you know, outputting an address to this. So I'm going to go ahead and do that, write a few routines to do that for my output and I'm sorry, this is not the EEPROMs, the 74100 latches. So I'm going to do that for the output board, the input board, and the ROM and the RAM cards. Make sure that they're all working okay, so that before I do the processor card, I know that at least I'm getting good values when I go out to do an instruction fetch. I'm also making a little EEPROM card that I can use a 2732 EEPROM and you know, just directly decode that, and that's going to be just simpler. It's simpler for me to program a 2732 than the 1702As. So that way I'll be able to get code in this, and then I can fire up the processor directly using this card rather than the 1702s. And also this will, I'll probably put on this card another interface to my 8010B, so I can use the 8010B on this card to get onto the backplane bus when there's not a processor in here, to basically replace the processor board with this card so that I can use the EEPROM programmer on the backplane, and also it'll give me another chance to test all of the I/O and the memory. So I got to finish this one out so that I can use it for both an EEPROM and to test the backplane and all the cards using my 8010B when everything's assembled. So I got to finish that one up also. Okay, so that's my status now. I think I have the code ready to test the output board, so that will be the next project for this afternoon if I get to it, or tomorrow, and I will let you know how that goes. So maybe I'll have a video on this where I do that, a little bit more discussion on that. But so far so good. I think any issues that I had will probably be corrected, as I said, when the next version of the boards come out, but this is still a fun project. Okay, well, thanks for watching, and if you have any questions, let me know.